What I'd like to do now is talk just a little bit more about AES 67 and SMPTE ST2110 and the relationship between these two standards. So these are significant open standards. They've emerged in the last several years, and they're providing quite wide-ranging interoperability for professional media networking. And they're the core standards really in the AIMS roadmap. AES 67 has been around a little while now. It was first published in 2013, and it's been updated in 2015 and again 2018. It's always maintained backwards compatibility, but those updates have added some clarifications and some other improvements without breaking any backwards compatibility. The SMPTE ST2110 suite of standards, the initial sections of that were published in December 2017. And quite often people wonder, what is the relationship between these two standards that are both key parts of the AIMS roadmap? So let me look back a little bit at the AES 67 standard to tell you how that developed and what its goals were. So the original goal for AES 67 was to provide a method to connect disparate audio over IP systems to achieve workaround-free networked audio interoperability. So before AES 67, there were a number of audio network solutions available in the industry, but they weren't able to connect to one another, and AES 67 was intended to rectify that situation. It's defined as an interoperability standard for high-performance audio over IP networks. And importantly, it's based on existing and trusted IT standards. So that's important to ensure compatibility with existing network infrastructure and also to allow coexistence with other IT data. So when the AES Standards Group began working on what became AES 67, they began by establishing a problem statement. And at that time, audio over IP, or networked audio, was recognized as providing simpler and better connection between audio equipment. But along with those many advantages, there was one clear challenge, which was compatibility. As I said, at that time, there were a number of audio over IP solutions. They could all communicate within their own solution. In other words, a whole network of Dante devices or a network of Ravenna devices could communicate within their network, but they couldn't talk to one another. So simple diagram here would show something like a Dante network. This might be, let's say, a live sound system in an arena. Everything within that Dante network is talking to each other and working well. But then you have maybe an OB truck comes to the arena. It has a Ravenna-based network inside. You may have an output system in the arena that's using QLAN. And before AES 67, you had to find ways to work around interconnectivity between those different network solutions. And people were using multiple AES-3 lines, or maybe MADI, AES-10, or they might even be using analog connections to get between these different incompatible network solutions. So AES-67 set out to solve that shortcoming. To look a little bit at how this road to incompatibility developed, we see here along the left side of the screen the different elements that are necessary when creating an audio network solution. So we have things like media clocking, synchronization, quality of service, and so forth. And each developer of such a solution needs to define how it's going to meet each of those requirements. And we can see some of these different audio networking solutions and the choices that they have made, different protocols, different standards, different specifications to meet each of these requirements. Quite a lot of commonality between the different solutions, but enough areas of incompatibility that they simply can't talk directly to one another. And that's where AES 67 comes in to solve this problem. Now, at the very top, we have control and monitoring. That was defined as being outside the scope of AES 67. AES 67 was all about audio streams and getting them between network solutions. Control and monitoring wasn't absolutely necessary to achieve that. So AES 67 then defined common protocols and specifications to meet each of these different network requirements. It's worth mentioning up near the top, discovery. They decided not to go with a mandatory method of discovery for various reasons. There was concern that if they went with one mandatory discovery method, the uptake of AES 67 might not be ideal. Some companies might not be willing to accept that discovery method. Also, it was recognized that things are continually evolving. You can see what AES-67 has done is it has referenced a number of different discovery methods that could be used between these different networking solutions. This includes now the NMOS ISO 4 specification, which didn't even exist at the time AES-67 was first ratified. It also includes SAP, which is Session Announcement Protocol, which is not mandatory in AES-67, but is supported by the vast majority of devices, so this does tend to be a common way of doing discovery. So AES-67 established a baseline of common protocols and standards to enable this interoperability between these different network technologies and solutions. Importantly, those network audio systems that we've mentioned along the top there, for example, are complete solutions, where AES-67 was not intended to be a complete solution. It's simply a mode of operation to connect and provide audio interoperability between the existing complete solutions. And therefore, AES-67 complements each of those solutions. It does not compete with them. And as a result, we have these different audio networking solutions. They all connect, they're all using IP, but they can't natively speak to one another. AES-67 then provides the solution that allows them to do that. So that's a quick overview of AES-67. Then I'll take an even quicker look at ST2110, which is obviously a very big subject, and we have other presentations here going into much more depth about this, but I want to look at ST2110, particularly as it relates to audio and to AES-67. So ST2110 is a standard for transport of video, audio, and data over IP networks, and it's primarily for broadcast applications. And we can see from this diagram here, it's carrying video and audio data as separate flows, as separate essences. It's providing a very flexible alternative to SDI for real-time systems, and that flexibility extends to areas like contribution, production, and playout workflows. Now, coming back again to the fact that ST2110 is a suite of standards, and here we can see the initial sections of that suite that have been published up to now, and there will be more coming in the future. So we have what's called 2110-10, which defines timing and other system definitions. -20 is about uncompressed video. -30 then is the uncompressed PCM audio, which is based on AES-67. -40 is for ancillary data. -21 is for what's called video sender traffic shaping. We have -22, which is a very recent one, which is about carrying compressed video over IP. And -31 for fully bit transparent AES-3 data. So I want to look specifically, though, at the audio side right now to explain a bit more about the relationship between AES-67 and ST2110, particularly -30. It can be said that AES-67 is the basis of 2110-30, but does that mean they are identical? Well, no, they're not identical. So here's a diagram that tries to show this in a bit of detail. We like to say that ST2110-30 is a constrained subset of AES-67. And the constraints are intended to provide better interoperability by defining a tighter operating point. So here you can see in this sort of sphere of light blue, we have the whole AES-67 standard. And in the center, in the sort of purple area, it says AES-67 mandatory. So those are the parts of the standard that are mandatory requirements. And then around that, you have a number of optional requirements. Then we have what's here referred to as ST2110-30 level A. And these are the primary operating points, which define things like a 1 millisecond packet time, 2 and 8 channels per stream, a common PTP operating point, and then importantly, an RTP offset of 0. Now this is, as it says there, unique to ST2110-30 because in the AES-67 standard, that RTP offset can be a random value. So this is one area where they're not identical. Obviously a random value could include 0, so there could be complete compatibility between the two. But in an AES-67 standard, if they don't set the RTP offset to 0, you could have incompatibility. That's becoming far less of a problem recently now as the people that are developing AES-67 products most of them want to be also compatible with ST2110. So they're now, sorry? Oh, real-time transport protocol. I'm going to, we have actually a white paper that explains all this in much more detail. What I'm trying to get across here is simply that this is something you might need to be aware of. If you're using an AES67 implementation that was not designed to be ST2110-30 compatible, and remember, AES67 predates ST2110 by 4 or more years, you may have an issue that you need to be aware of. As I said though, more recently the developers of AES67 equipment are starting to update them to become more compatible with ST2110-30. So it's really becoming more of a footnote now, not such an important thing, but something that you might just need to be aware of. And you can't just assume that every AES67 device will be completely compatible with ST2110. Oh, this is ST2110 is from SMPTE, Society of Motion Picture and Television Engineers. So that's the primary operating point. There are other operating points that are designed to achieve other things. And this is where we go more into the optional areas of AES67. So level B and C both define a shorter packet time of 125 microseconds, which is valuable for low latency live production. And level C also takes that up to 64 channels per stream, which is very similar to MADI. So those are things you can use in ST2110 that are not incompatible with AES67, but they're not part of AES67's mandatory requirements. So as I said, we felt it was important that people understood the relationship between these two standards. So AIMS has produced a white paper that looks at the commonalities and constraints. And it points out that in the vast majority of cases, the two standards are very common. They have many things in common. But there are a few points where there are some constraints applied to ST2110, and you might need to be aware of that. So we have that white paper produced by AIMS, and it's available here. We have some printed copies here, or you can download that from the aimsalliance.org website.